All right, hello everybody. Hello, hola, everybody. I don't know any more languages, maybe. So I hope that everybody is okay. Uh, I'm Paco Francisco. I'm an iOS developer at ECC. I develop mostly the ECC wallet and the Zcash SDK for iOS. And today we're going to do a small workshop about a point of sale application that uses viewing keys to, charge and accept Zcash in a hypothetical mom and pop's store, a small like store around the corner. And the idea of this application is to just that a merchant that has an old iPod or like iPhone 6 or iPhone 7 that is like maybe a little bumped up, and at the end of its life it can turn into a nice PoS terminal to accept payments in Zcash. So, and well, and if you have any questions, you have this the question dashboard there, where you can check the chat. I apologize if my computer is moving a little bit. I see that somebody says I'm getting seasick. I apologize. I try not to move a lot. I'm kind of in the beach house, so I don't have a desk, so I'm really, 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 really remoting. So I apologize for any movements. But we're going to start sharing the screen, and you won't see my face bouncing up as if I were like in a raft. All right, so let's share the screen and start with this little workshop. I'm gonna share my entire screen, and yeah, I close everything out. All right, so let's see. I don't know who of you guys knows Zcash already. As you know, Zcash is a Bitcoin core fork that started to implement CK Snark technology into a Bitcoin fork and Bitcoin related technology, and it's known as a privacy coin. And Zcash has this particular mission of believing that privacy is a right, a human right, and that it's really, really essential to the economy and life in general, and that there's no possibility of developing a crypto economy for real without privacy. So Zcash tries to bring that piece to the crypto world. So we see Zcash being to digital money as HTTPS is for the web. So you mostly I suppose that you mostly know which is the difference between HTTP and HTTPS. And what Zcash has, it's two kinds of transactions that are unshielded and transparent transactions, which are really similar to what Bitcoin transactions are. We call those transparent transactions. And as a Zcash user, you will have both a transparent address known as a T address, T as in Thomas, and also a shielded transaction in which are done by shielding transparent transactions or using your sapling Zcash shielded address. So this kind of address scheme creates a really interesting and particular way of transacting that is a little bit different than other cryptos, where you have, private transactions that are transactions that go from a Z address to a Z address, and we have the shielding transactions that are transactions that go from a Z address to the transparent address, and then you have a shielding transaction where you go from a transparent transaction to the shielded address, and then you have the public transparent ones, which are like T2T. So you will also hear them as T2Z, Z2T, T2T, or Z2C. That's the jargon. One interesting way of using Zcash is transacting and adding encrypted memos. When you have shielded transactions, you can also append an encrypted ciphertext of 512 bytes, and you can add whatever you want there, like a message, or maybe it can be some bytes that your app reads on the chain that's programmable to do some programming stuff. And for example, there are apps that run on Zcash, like Zbay, that implements marketplace and chat using the memo fields. And it's really interesting. And basically, our mission is to, as I said, to bring privacy to the crypto world. So that being said, a little bit of introduction. My name again to the latecomers is Francisco, or Paco is my nickname. And you can find me in GitHub and github.com/Pacu, Pacu. And let's get on with this. Let me check if there are any questions here. Yes, Zcash. Stephen, who was seasick before, now says that Zcash is awesome. So Stephen, I hope that you're not seasick anymore, and I hope I enjoyed that you actually love Zcash. I love it too. So what are we going to do today? I have a lot of tabs here because I'm going to just show you what we have in the docs and in the in our blog. So I'm going to use just available information. We do everything open source, and some people would say a little bit too much, but we like to work in the open. And so we're going to visit our repos and our page. If you think that we could do a better job at documenting or anything like that, I'm going to just do a little announcement. Electric Coin Company has open positions. So if you go to electriccoin.co, and the site is new, but yeah, in company, in careers, you're gonna be able to just see what the open roles are and apply for them if you see that's suitable for you. If you imagine that you want to be a part of Zcash, you can. A little bit windy now outside. I don't know if you hear me well. So that's the little announcement. Just check the career section of our webpage if you want to join electroncoin.co. All right. So our project is going to be a little point of sale application, which is here in the Zcash Hatworks GitHub page. is where we have like informal projects and things that we want to check and test and do proofs of concepts. So we're going to make this app, which its goal is to just accept Zcash and be able to have an app that can receive transactions but does not have the ability to send that money elsewhere. So we're going to do 8 steps along the way to build a small Swift UI application that uses our Zcash SDK. And there's no need to know any iOS in particular to understand what's going on. My idea is to just explain how Zcash works and what in a conceptual way, and not focusing that much in the mobile part. All right. So how can we uh, create an app that has only the ability to see what's in a particular set of keys, but does not have any spending authority? That means that the person that has the device in their hands has no possibility of extracting a seed or a private key and just send that money elsewhere, and do a just stealing from the cashier, from the cash register, or whatever it's called in English. Um, so there's a little feature called viewing keys here in Zcash. There's a blog post from last year, May 18th. That seems a really, really, really long time ago, and that explains a little bit viewing keys. What a viewing key is a derivation of your seed from your private key that only has viewing abilities, and depending on what kind of viewing key you derive, you're going to have certain granularity on controlling the level of privacy and level of visibility that that key has. So, for example, we're just going to sync the blockchain with a viewing key that will be able to see incoming transactions and not really anything else. And there are certain ways where you can actually just use like view particular payments, and which is called selective disclosure of that you can see in this blog post too, which is that in addition to viewing keys, you can create certain disclosure keys that can provide additional information for a particular transaction and not the whole set of transactions associated to those keys. So Zcash is private, but also lets you control who sees what, which is a really, really core concept of privacy. So I don't know if there's any questions about it. Just let me know. But I assume that if there are no chats or anything, interruptions, that there are not. So our first step for this, it's going to just create an Xcode project. I have everything pre-baked here like a cooking show, because the demo gods.
Paco, sorry, we
Yes.
actually have a question from
Oh,
Steven.
awesome. Yes. Does this include a memo field? I guess the answer is yes, depending on what you refer to with the word this. We're going to use memo fields to know who's paying for the order that is being done on the application. So we're going to use memos, and the app is going to display the memo field for each received transaction so that we can know what is it for easily. Remember that this is just proof of concept, and the app is not like fully functional. It does work, but if you want to just bring it to your own like store, well, it might need a little bit of more of work, specifically because it's just per thing is a little bit ugly. But we're gonna have a challenge in the end to make it little bit more good looking. So the way to approach this workshop is to just clone this repo and just go tag by tag and just do the steps. Try to do the steps or reproduce them along in a different project, or just look at the steps in the same project as you wish to. So we're going to go to, I've already checked out the step 0. So let me reset this. So, all right. The first thing we're going to do here is that we need to create a project for the Zcash POS using Swift UI. So usually that's done by just going to File, New, Create a Project, and just not workspace project, and just create a new Swift UI thing, an application, and you tell it that you want a Swift UI, and you can put the name here like we accept Zcash POS. You do next, and you select everything out there, and that's it. That's really simple. One nice thing about Xcode and Swift, that's really straightforward to do stuff. So, okay. So what do we have here? We have the project in the workspace, right? And let's see what we have here. So I'm going to open this up. All right. I don't know if you can see this Finder window, which is a little bit small, but we have some important things. First, we just have this small workspace and project file, and we're going to use the workspace because we're going to use CocoaPods as a dependency management. All right. Let's see. There we go. And we don't have much yet. We just have a little hello world screen and nothing else. So let's see what we can do and how we're gonna just reach the end of this tutorial. But first, I want to just give you a little sneak peek on what the end of this app will be. I don't know if there are any iOS devs here, or just Zcash enthusiasts or Android developers. Just raise your hands. Okay, Stephen says subset of transactions visible on the viewing key. Zcash is cool. Awesome. So let's see how this goes. All right, we're going to do an iPod thing. So I'm going to open the iPod Touch device, and here's where the big thing is. Okay, there we go. Accept Zcash. So the app is going to look like this. We're going to have 3 screens, one to generate an order, a history, and some settings. And for now, we're going to nuke this thing. And there we go. And this is what the little app is going to be. Okay? So, all right. Okay. So, the next step is going to be initializing the project with the SDK inside. So the SDK is pretty straightforward to use. We try to make it as this is 90s word, just plug and play as possible. But it's important to know a few things about it. So if you go to the Android repo, it has some nice diagrams about how this thing works. So since devices have resource constraints, even though like new iPhones and new Google Pixels and all that have like awesome capabilities, the blockchain is still a little bit big for running a full node in your phone. So the way to sync Zcash in your mobile phone or any light client, it could be a light client in your desktop, like Zec Wallet, for example, and not running a full node in your machine, is to use a Light Wallet D server, which is going to give our application a reduced and compact version of the blockchain. This is done through a lightweight light client protocol and designed in the zip process, which is the Zcash improvement process for adding features to the protocol and all that. Bitcoin has BIPs and ETH has their own as well. But the idea of this zip that defines like light clients is to establish that there's going to be a server which is going to connect with the Zcash full node and generate a compact version of the chain that is 90% lighter than a regular like the regular blockchain. And this lightweight version of the blockchain only has like the shielded part of the protocol. So in this exercise, we're just going to focus on shielded transactions. And the idea of the SDK is to be able to download the compact blocks from the blockchain. Let's hear this little, let me see if I can make this bigger. Yeah, maybe. And download the compact blocks that are served by the Light Wallet server and store them in a cache inside of the application's sandbox, so that after we have our blocks, we can process them and scan them and sync the compact blockchain inside the device. This is being done by a Rust library called librust Zcash. librust Zcash. Yeah, there we go. Everything is open source and it's on GitHub. So this librust Zcash thing, it's a collection of Rust crates that allows developers to have certain Zcash primitives and backends and SQL like storage and a lot of facilities to create like clients. So your cell phone, your mobile application, it's in fact going to use Rust code to process the blockchain and do what they call the moon math to generate the proofs and verify the zero knowledge proofs and decrypt and encrypt. So all that will happen in the Rust layer. And for the Android side, there's going to be a JNI boundary, a Java native interface that's going to talk to the Kotlin side of the platform. And for iOS, is going to be a Rust side that's going to have a small C interface where Swift is going to communicate through that to do all the awesomeness like scanning the blockchain and all that. So the main thing that we have to know is that even though the SDKs have all those moving pieces that you can pull apart and make it your own, we're going to use a pre-baked component that is called the SDK synchronizer that is going to help us to do the main thing, which is like loading your keys, hitting start, and have it sync. All right. For this exercise, I'm going to use a Light Wallet instance in the cloud that we already have for our internal development. But there are some public ones in for Nighthawk Wallet, for example, or you can actually just run your own, which is a nice exercise too. Okay, so back to it. Where is this step? Here. So the step one is to integrate the SDK, right? So for this, what we're going to do is to integrate the Zcash Light Client Kit, which is the Zcash SDK for Swift. And all the instructions of how to do that correctly are in the GitHub repository. So you can actually, follow them step by step, and you should mostly be good to go. But don't hesitate if you feel that there's something that no longer applies or you're struggling with to send us an issue, and we will fix it right away. We really value people just jumping in, creating, issues and sending us PRs. So you'll have here a lot of instructions that I'm not going to cover right now because it would be a kind of a long workshop. So let's get back to the step one. So we integrate the SDK, right? I'm going to go to, clean. All right. Okay, so I'm going to check out this tag. Uri. Oh. Okay. So let's see what we have here. we do have now a pod file and a environment workspace to work with. So what we're going to do here is just to do a pod install and see how it goes. So when you integrate the Zcash client kit, it's going to integrate a bunch of libraries, which are basically a NIO network layer and the HTTP2 gRPC capabilities, because our Zcash and Lightwell instances run on gRPC. So the SDK is going to communicate through that. All right, so I opened the workspace. I'm going to close a little bit of the 1,000 windows I have here that mostly don't exist yet. Okay. So, okay. Let's see how this goes. Open the workspace. Okay. And we're going to have here, let's see if it runs. I'm going to run it in a different device. And let's see if it works. I hope the demo gods are nice. So far, so good. So our main screen for now is going to be just little text on a white screen that's going to say, "Hello, Zcash," and it's going to use the SDK to know if it is in mainnet or in testnet mode. You can build the Zcash SDK for mainnet or testnet separately, and it's better for those not to mix in one app, honestly. But in the future, you will be able to switch gratefully between those two as well if you want to. We treat them separately for now, and but it's also possible to have an app that actually uses both. And since we take this workshop seriously, we're just going to use mainnet in real money because it's funnier that way. All right. So this build is taking a little bit because it has to build a lot of things. So are there any questions down there in the chat? Not for now. Okay. So we're going to use Swift UI, but it is possible not to do so and use iOS UI kit, like the traditional way to do iOS apps. So the SDK has compatibility for iOS 12 and newer. Our idea is that we can include the most amount of public as possible. Like our audience is the most kind of users that are around in the world, and we try to stick to 3 versions if possible. 90% of user reach for each platform. That's our target. It really depends also on the manufacturers sometimes and how they deprecate stuff, but we try to keep it available for everybody because that's kind of the mission of crypto and specifically of Zcash. All right, so we have a simulator here, and let's say it says hello Zcash mainnet. Awesome. So this thing works. Whoa, I was kind of scared. The demagogues sometimes don't want it to work. So we do know a couple of things here. That we have our app running, in that we were able to import Zcash Line Client Kit and call one of its functions to know if we're using mainnet or testnet. So the next step is going to take a little bit of care about the looks of this app. Okay, so let's see. All right. Okay. So let's check out the next step. Ooh. Mm-hmm. Did I misspell that tag? Yeah, the looks. I'm gonna fix that later. Okay. So this step is a little bit boring because we're going to add some prefix UI elements. To be honest, we are everything's open, so we won't be stealing. But yeah, we are stealing from our ECC app some of its UI components, so we don't have to work too much, and that's fine because that's what the ECC wallet is for. It's just to use it as a reference in your own apps. So everything there in that repos, it's up for whoever wants to use them. So that's that. So I'm just going to pod install again just in case. This is probably not necessary because we didn't modify anything at the dependency level, but just just in case. Okay. All right. So here on the UI elements, we're going to use a background. We're going to have some text fields and some colors. So for example, if I wanted to just have a nice, like, darker theme, that's what we're going to do. We're just going to add this little component that has a nice gradient over. And we're going to change this text to white. And let's see if it works. Woo! Yeah. And there's something called Zcash logo as well. So let's see if we can add a Zcash logo to it. We're going to add a component that is called vstack that just stacks things vertically. And we're going to just call it Zcash logo. Let's see if it works. Ooh, yeah. That looks better. So let's see what else we have here. If you check the UI elements folder, you will be able to see that we added a bunch of things here, and we're going to add a bunch more. For now, it's just a set of colors. This is the color palette of the ECC wallet, and just the Zcash background and the Zcash symbol for now. So what else? Our next step is going to be importing the viewing key. So we want to import the viewing key. The step would be that, like, if I'm the owner of the shop, I want to be in control of the spendability of those funds that come in. So I'm having like a different. I can use a different wallet to derive my viewing keys, and then I'm just going to load them here so that I can import those viewing keys and sync the blockchain with it. All right. So let's see. Okay. So now we're going to go to step 3, which is that we're going to create a just a small screen that has 2 text fields and that let us just import a viewing key and have a birthday too. And I'm going to take the advantage of this to explain a little bit what wallet birthdays are. Oh, okay. So we have some new things here that we're going to explain a little bit before just going forward. All right. On the README, you will have some little snippets or explanations of what changed and what's the idea of this change. Okay. So if we see, we're going to have a little bit more of UI elements imported on this side. Maybe the sidebar is a little bit small for you guys to see, but the former content view, the former boring content view, now has been, upgraded, and it's called import viewing key, and that's going to be our first screen. When we first start the application, we have 2 situations. One is being that the device that we're using has no credentials on it to put it in a way. It has no keys loaded into it, so it's empty and uninitialized. And then the other future state would be that once you loaded your viewing keys there, you're going to have a different workflow where you can start to request payments to customers. All right. So we're going to have to create, take care of this first step. So we're going to add just 2 text fields that we have some nice custom text fields here that have a Zcash look on it with the characteristic dark gray and yellow themes and gold yellow themes. And you would notice that it says paste a Zcash viewing key. We could do something like scan a QR as well. For the sake of brevity, we hadn't include this in this particular app, but you could encode the viewing key, which is a really, really long. Let me show you what a viewing key is. So a viewing key starts with CX views 1, and it's a really long string. And it also has a wallet birthday. And if you see here in this other text field that I'm selecting here, it says the title of this text field is your key's birthday. Essentially, if what we created here is some checkpoints where our SDK knows particular intervals of block headers, so that if you have a new wallet and you know that you created a wallet at a certain height, you can start syncing your wallet from then on, and you don't have to sync the whole compact blockchain, which it is compact, but as time goes by and blocks are mined, the chain gets longer and longer, and you don't want to process blocks and download blocks that you don't need to. So the concept of the birthday is just to know when these keys were born and sync them from then on. And you could also pinpoint your birthday, which would be like the first received transaction that you have for these keys. So for us, it's going to be this block height, the 1,153,000. Okay, so in this scaffold, what we would do is just to copy paste. I hope paste works and it's not buggy. Sometimes it's buggy. And we're going just to input our birthday. And this screen does nothing yet because we have more steps to go. But this is how the app is going to look. Okay. Okay, so let's stop the simulator. A bunch of dogs are barking. And let's see what the next step looks like. Okay. So I don't know if are there any questions. No, I don't see any. But just jump in if you want to ask something. All right. So the step 4 is going to, import the viewing key for real and sync it. So what we have to do here is to create a Zcash environment. The Zcash environment is basically how our app is going to instantiate the SDK and use it. Our SDK needs a couple of things. And the first thing, sorry for the dogs, and the first thing you need is to know where the Lightwell ID is located. And you need to, do a local host if you're running it locally, or a URL, Then we're going to use the combined synchronizer, which is an adapter of the SDK synchronizer I showed you before, which is also borrowed from the ECC wallet. Okay. And then we need to set up some paths to let the SDK know where the databases that Libra Zcash uses underneath are going to be. Since these are your keys, this is your data. It's going to live on the sandbox of your phone. And so those are managed locally, and they're not backed up anywhere or anything like that. So everything is going to live locally on your device until you delete that. So make sure always to back up your seeds before deleting stuff. And there's some special secret sauce that Zcash has. This is not a secret sauce. It's called often the trusted setup parameters, or also the toxic waste. Zcash, to create the proofs, the zero knowledge proofs, needs a multiple party computation. The last one for sapling was like I think, if I'm not mistaken, like 88 people from all over the world computing these parameters. There are utilities on the SDK to download them on the fly, but for the sake of brevity, we're just going to bundle them in. I downloaded them and bundled them in to the app, and included those files into the git ignore so they don't bloat the repo. So we don't need them in the repo itself. Okay. So let's see how this goes in code. Okay, great. So we created this Zcash environment class that's going to contain everything that we need to spin up the SDK. And then, did I check out the correct tag? No, I haven't. Let's go to step 4. All right. Okay, so now we should be able to see some changes here. Yes. Okay. I added a bunch of stuff. Some things are we're going to need later, and some things we're going to need now. Something to note is that the SDK has a logger interface. We don't log anything, and so, but there's a chance that you might want to have local device logs for development or for your users to have. Um, you know, recently, like Signal did I think Signal was that did a local logs donation request for users for an inconvenience they were having. The idea, as a privacy coin, is to, not snitch you in our code does not snitch you out or does not rat you out or spy you at any level. So we don't add any more spies to what you already have in your mobile phone. Unfortunately, that's quite a lot already. So we have the Zcash PoS model. This is a little class that's going to be an ugly MVVM pattern here, which is going to contain stuff related to the application, like how's the navigation going, what is the viewing key, what is the wallet birthday, um, and which is the initial screen, and all that. So let's try to build this step and see how it goes. I hope it builds. Maybe it doesn't. Ooh, okay. So, derivation tool. All right, let's see. File. Okay. Okay. I did a little cheating here, which is I added some things and also fixed some other stuff in the SDK while I was cooking this workshop, and I didn't polish that yet. So that's why it's complaining, but I'm going to fix that. Okay. Doing this. You won't need to do this because by the end of this workshop, what I'm going to do is just to create a new version of the SDK and publish it for you guys to have it. All right. The bad thing of this is that it's going to build everything again. The machine is kind of burning my legs, but that's fine. Okay, any questions? Is there a way to see record a video? I think that's a question for you, Sylvia. Yes, it was already answered. And okay.
Yeah, I
Not,
think
yeah.
it's the how did you generate the viewing key? I'm not so sure if you answered that one.
Oh, how did I generate the viewing key? Oh, yes. Let me show you the code. I think it's here. Uh oh, some wind here. All right. If you keep menu active, yes. Yeah. Okay. I did a little preview here on the wallet repo, and I actually used I created a screen on the Zcash wallet that actually did that derivation. Basically, um, the SDK has a tool called the derivation tool, which has a lot of perks about deriving your seed and your addresses and all that. And there's a small method called derive viewing keys, where you can actually put a seed on it, and it will derive the number of accounts, your HD wallet path, and all that, and it will give you the viewing key. I don't know if that answered the question. Okay, so let's see this finish running. Okay, so let's see how it goes. I have my viewing key already derived here, so I'm going to again paste it. Oh, crash. Okay, the demo gods were angry. Let's see how it goes again. Oh, demo code. You can crash. It happens. All right, paste thing. All right, and now I'm going to input my birthday, and yay! Here it goes. So we have a new screen right now, which is the following screen or the home screen. The home screen is going to be where we're going to land after importing a viewing key, or just opening the app afterwards. You're seeing that the SDK is saying error and failing. That's because I did not enter a working server. So it's just saying, okay, man, I'm trying to connect, but localhost has nothing. So let's see. Let's fix that. Let's see if I can electriccoin.co. Was that it? Let's see. I miss line. Oh, all right. Yeah, we that are not native speakers have trouble with the words light, height, width. All right, so we have the server there, and we're syncing the chain, and it's chewing blocks like crazy and all that. So everything's going really fine. Um, Syncing is a vital part of any Zcash like client, and if you want to do shielded stuff, you will have to rely on it. For the transparent part, it's really similar to Bitcoin. You can use the API that now I can't recall the name, Insight, for example, or you can just use the RPC calls on Light Wallet D, or you can do a backend with your trusted Zcash node and get all the things from there. It's like a normal a Bitcoin client would do. What you just saw is that the SDK is like a ticking clock. Like every few seconds, it's going to try to check the blockchain for new blocks and sync and keep itself to like the latest height. So you just leave it running, and it's going to do its thing with certain limitations on background work around what each uh, operating system restrictions are. All right, so we have this thing going, and I wanted to show you like the Zcash environment where everything happens. That the combined synchronizer is, in this case, your friend. It has a lot of things. It does a lot of stuff. But it basically hears, the ticking clock, the engine of all the things. And we're going to get our receipt transactions, our status, our progress, our, everything from here. So, and here you can see that the synchronizer, to be initialized, it takes a set of viewing keys, and it holds them. So there's a particular button here that is really curious, which is the stop and nuke. We have this concept of nuking a wallet. So we figured out that since we have so much state when we sync the shielded transactions, that it's good to have a way of safely deleting everything and cleaning out the app before deleting it. So our ECC wallet, for example, has a nuke button where in the profile menu where you can actually just delete its contents, and it will actually shut itself down. And next time you start it up, it's going to be fresh new. And it's a concept that we found really helpful during the development because you have a lot of accounts and all that. But also in real life, sometimes you just might want to delete your stuff for any reason. So you can do it easily. All right. Any questions, any doubts, things I might be missing? Here's a little snippet of code that is showing you that how the birthday and the viewing key string are used to initialize the app. And our home screen is, and our app in general, is going to have 3 states: ready, syncing, and offline. I made this app with the idea that even though you're offline for any reason, you can still show a payment code to a customer. And well, you maybe have to rely on them checking out their wallet and telling you the confirmations on their end. If, I don't know, if there's a power surge or anything like that, but you can still receive payments without having like electrical power. That's something really that catched on the last few days. So there's that, and let's see what the step 5 is. Did I stop this? Yes, no, okay. All right. Okay. Yeah, misspell that one too? Probably. Huh, I don't have step 5. That's embarrassing. Okay. I'll just have to create that tag later. So let's get the next one. All right, and it's going to help us go a little bit faster because we're kind of running out of time. Okay, so the step 5 is actually something related to the UI mostly. And what we're going to do is to create a tab view. And our application is going to have 3 tabs. One is just for, selling, which is requesting like the payment to the customer. And then the receive transactions, there's going to be a screen where we're going to show the list of decrypted transactions for these keys, and a settings screen where everything else is going to go, like the nuke button or anything else that's not those other 2 things. Okay. You're going to see that there are some weird functions along the way, like this one, which is like navigation bar look tweaks and all that. Swift UI is still beta software and it's not fully baked. So to make it look nice and customizable, we had to do some tricks there. So some work, some others don't work anymore. But yeah, so if you're interested in Swift UI and you want to know how how to work with it and what the experience we had with it, you can look at those things as well. It's interesting. And we're going to see that this screen, the home screen, is going to be getting the viewing keys from the app storage. The viewing keys now are going to be just at plain sight. You can decide whether that's suitable for you or not, if you want to put that in the keychain or whatever. We're not going to cover that for now, but you could if you wanted to. And it's going to start the synchronizer, initialize it, and start it. Okay. This step does nothing when your synchronizer is already initialized, but since it's the same scenario whereas you are coming from the importing key screen or not, we just left it there. And then, as I said, you just with the synchronizer you're mostly covered, and you need to start and stop it when you want to, and that's it. For any errors, we're going to throw an alert, and that's pretty much it. Okay, so let's see how this step 6 goes and what it looks like. Oh, maybe it doesn't work. That would be interesting. PoS file lock updated. Okay, so this I need to do this again. Sorry, but it's just as real as iOS and CocoaPods get. So if you wanted to know, yeah, that's pretty much like working with CocoaPods is doing this kind of things. It's awesome, but it has its nuances. So we're going to do pod install to. Oh, there's some wind here. Okay. The pod install is done. We're ready to run, and let's see how it goes. Okay. Now it has a better look. We've created now a screen that's used to request some amount of sec, and we're going to append an order code. This could be also a Zcash payment URI. We haven't implemented that yet in our mobile apps, we need to kind of do the parsing stuff. But there's a zip around that is called zip 321 about how um, the scheme, the URI scheme for Zcash payments is. And if you want to check it out later, you just go to zips.zcash and .z.cash, and that's where all like the nitty gritties of decisions of like the protocol and all that is. So if you're curious about how payment request URIs done in Zcash, you have all the specification here. And unfortunately, we haven't implemented yet in our app, which is kind of unfortunate, but that's the reality, I guess. Um, we are a small army of peaceful people. So let's say I'm going to send like buy some 1 sec or something, and then I would just um, input a code, and I could request the sec, um, and this is going to show um, the customer says pay with sec to this address, just 1 sec, and append memo with this code. Our idea in this hypothetical application is that when somebody is at the cashier line, the person just send us the payment to this address um, with this code, with this blurb here. It could be an order number, it could be an invoice number. It really depends on how things are managed there at that hypothetical store. But yeah, this little address is, not useful at all. So we're going to try to convert this to a QR code. All right. So basically, this is the sell screen, and then the history is where our transactions will be. That is what we're going to be doing really soon. And the settings where the fun nuke back button is. Okay. All right. So any questions? No questions. All right. So let's move over to what's next. Step 7, which is step 7 request sec QR code. Okay. Stash. Going to check out this thing. Oh. Okay. So now maybe I break everything or not. Okay. All right. So we had this problem where we were trying to to show the customer a text address, and it's not helpful at all. So on the request set Zec screen, we are going to use again some components from the ECC app, which is a QR container, and we're going to use some resources as well to show a QR logo overlay on top of the QR with a nice shield, and some other things if it doesn't go well and it fails. And we're also going to use this helper class, which is called QR code generator, which it's only like a wrapper class around just OS functionality in this case. Um, like iOS got you really covered on QR generation and all that, but the interface is a little bit rough. So I created this small wrapper around it so it will play, nicely with SwiftUI, which is like newer fancy code. So let's stop talking a little bit and run it. All right. So I'm typing with the keyboard. We could use the overlay, but it would be me like just tapping numbers here, so it would be slower. So we're going to request 0.0123, and we're going to input our super not random code, and now we have this little small QR code. Let's see. Did I sync my wallet today? I hope I had. Okay. I'm going to um, run my ECC wallet, and I'm going to try to scan it and see how it goes. Oh, still syncing. Okay. 40%, 60%. So I'm running my ECC wallet, and I'm going to see if I'm able to scan this code. So I'm going to send myself 0.0123. Okay. Oh, I don't have that money. Wait a second. Let's input a smaller amount because this test wallet doesn't have that much ZEC. Okay. So 0.001, just we had just a on the spot discount on this article. So I'm going to try to scan this out, and yeah, I think the QR is too small. So let's make it bigger. And let's see how it goes. Okay. SDF. All right. So I scanned it with my ECC wallet. I don't know if you can see it here. Um, and it works. So we have no transaction history yet. So let's move quickly to the next step. Act minus L, receive transactions. I'll get restore. Mm-hmm. Account. Okay. All right. So we are just about to see the full thing. Okay. uninstall. All right. So let's run the app and see how it goes. Any questions? Oh, Stephen says, I just mined your transaction. Oh, you imported these viewing keys? Yeah. That's why you don't have to show your keys to anyone. But cool. All right. Let's see. Or did you mine? I didn't send any yet, so I don't know. Maybe it wasn't. Good thing with the Zcash transactions is that they can't be spotted in the wild like Z to Z. Um, so that's fun. Okay. So building is taking a little bit now. So anyone has any questions? Nope. All right. Okay. So what do we have here? On this final step, we have done quite a lot. But the more interesting thing is the receive transactions. So the receive transactions screen basically just connects to the Zcash environment and asks uh, the synchronizer for the received transactions. It's going to attach to this event, to this stream of events of the combined synchronizer, that it will just send us the received transactions as soon as it's done syncing. Some wallets just there you go, receive transactions. This is a test transaction I did, and this is the another test transaction I did before. So we're going to go full demo, and let's try to send one right now. This will obviously totally fail, as in any demo, and the speaker would be just definitely ridiculous, as in any demo. So if there is an exception, it's going to work. Okay, so I'm going to input my no so secret test box, and we're going to see that this is syncing, and I'm going to request myself some Zec. 0, 2. Okay, and I'm going to say that my QR code is QWERTY. Hey, really original. Oh, it's too long. I had put a small length limitation here since we have to type it in the app. So let's request sec from my from myself. All right. Okay. I don't know if it's better for me to stop sharing and you see me full screen. Oh, hey. Okay. I have my ECC wallet right now, and I invite you all to just take a look at it and build it, make it your own. And I'm just going to quickly try to send some ZEC to this hypothetical store. So I scan my thing, and I'm going to put the secret order code, and let's hit send. Okay, I have to still look at it. It's going, and I hope it doesn't fail. It didn't fail. Okay, let's see the details. It says it has a memo, and my memo is square. Okay, so this is gonna take a few to be picked up, be mined, but I hope it does pick it up. Let me share my screen again, and let's see if we see it. So that's basically what we wanted to show you guys. Um, how to not so quickly, apparently, um, run a creative point of sale application with our tools. We encourage you guys to fork all the Android devs, if there are any in the crowd. Just be up for the challenge, and we encourage you to create this same app for Android using our Android SDK. And we invite you to just chime in with PRs and code and questions. And well, thank you very much for all of your time.